Okay, so welcome everyone to the June meeting of the Halifax Center. The land acknowledgement.
Yeah, now you're active.
I'm active, okay. RASC Halifax Center respectfully acknowledges that we live and observe on the unceded territory of the Mi'kmaq people. The RASC believes in and practices inclusivity and diversity. The Halifax Center welcomes all with an interest in astronomy without prejudice. So, photos. May was a somewhat better month for imaging. So we have a few nice photos to look at. Now, interesting thing about these photos, you'll notice that I'd say at least half of them were taken with one of the iterations of a smart telescope. So lots of people have been raiding their bank accounts to pick up S30 Pros. So Jerry got this nice shot of Messier 3 globular cluster with his S30 Pro. This is from SCO. Oh, probably backyard. Okay, so probably from his backyard. And the Rho Fuci cloud complex, again with the S30 Pro.
Where's that in the sky?
Just
there.
Yeah.
Red star, ball, Antares.
Yeah. So there's Antares, Messier 4. Lots of dust. So that wide field of view of the S30 Pro does a pretty good job. Although I think a mosaic would help, right? And the Veil Nebula, again with the S30 Pro. So supernova remnant gets the whole of it quite nicely.
I think that was a mosaic.
Oh, it was a mosaic? Okay. And Messier 81 and 82, along with the tiny little Garland galaxy hiding there in the corner.
And the bottom right.
And yeah, I forget what that one is.
Is there any filter on that one, Jared?
I believe so.
Yeah, it's an IR cut, UV IR cut filter, I think.
But I think I also.
Oh, you put one of your.
Turned on.
Oh, yeah, that's true. Yeah, I think you told me you used your quad band filter on this one. Maybe. Michael Beauchat's been leaning out his apartment window again. Got this shot of sunspots on May 2nd in his broadband, and with the he's got a Coronado solar telescope, and he grabbed this shot on the 16th of a hydrogen alpha image of the sun showing some quite nice prominences. And Venus and the crescent moon. So there's Venus, and the crescent moon, I think, is just over a day old at that point. And this is an impressive piece of work by Stuart Cameron using his C-Star S50, and he over a year he captured all the Messier objects. So pretty impressive what you can do with 50 millimeters of aperture. Dave Chapman, been looking at the moon. This is the waxing crescent moon for May 20th. Captured with a cell phone held over the eyepiece, I believe. And one of the best shots I've seen of the lunar X and the V from May 20th. Lots of detail here. There's the V. There's the X. So that's really impressive. And this is with a 90 millimeter. Was this with a 90 millimeter? Or the C90, yeah. So 90 millimeter Maxtottel Cassegrain. Jeff Donaldson grabbed a shot of the Lunar X right here. You'll see this is a theme through the month. The Crescent Nebula, again, the C-Star S30 Pro. I think this is a mosaic. So there's the crescent and all the surrounding dust and nebulosity in the Cygnus region. And this is a wide field view of the Cygnus region. So ZWO recently released a firmware update to the S30 Pro, which allows you to use the wide-angle camera and the telephoto camera at the same time. So if you're studying something in the area of Cygnus, you can grab a nice wide view of the Milky Way at the same time. And the Dumbbell Nebula, Messier 27, again with the S30 Pro. The North American Nebula, again from Jeff Donaldson with the S30 Pro. And he's got a mosaic he's working on, which also shows the Pelican Nebula, which you can just see the end of it peering in here. I did. Okay, yeah. Some people, and myself included, think this should be renamed the Deadpool Nebula. And the Trifid and Lagoon Nebula, another mosaic, again with the S30 Pro. I thought he said it was an S30. Yeah. Lisa Ann Fanning, the Lunar X and the Lunar V. And Venus and the Waxing Crescent Moon from Lisa Ann. Paul Gray's been sketching. So this is, he's got a sketch here of, he's had some good nights around Greenwood, and this is a sketch of a fairly diffuse globular cluster, NGC 5897. See it right here. I grabbed this shot of the waxing crescent moon on the 18th, just after sunset, so lots of nice color in the sky and some ominous looking clouds. And the coat hanger asterism, which I imaged with my S30 Pro. And you can see the upside down coat hanger. Lots of colorful stars. Peter Hurley, Lunar X and the Lunar V with the C-Star S50. Frank Logan's been honing his imaging skills, and this is a image of Messier 81, the Bode's galaxy. And Blair MacDonald, masterpiece here, Abdel 2218, which shows gravitational lensing. Can we see here, is it 1.5 billion light years?
The cluster itself is 2.3
billion, okay.
And the gravitationally lensed galaxies are 11 billion.
Okay, 11 billion. So this is a gravitationally lensed galaxy? Oh, okay. The lenses are in here? Okay.
You can't see them at that scale.
Have to zoom in, right? Yeah. But Pretty impressive for 120 millimeters of aperture. Not from the city though. Right? Yeah, St. Croix. You need dark sky, fairly dark skies. But
3 or 4 hours.
okay, so Blair said 3 or 4 hours worth of data to get this.
Sorry, Blair, what part of the sky is that in?
When that was shot, that was in the northeast.
Any nearby constellations that we might use to figure out where it is?
It's just below the arc of the handle of the Dipper.
Okay, so location just below the arc of the handle of the Dipper. So if anyone wants to try to replicate Blair's feat with a maybe 102 millimeter scope. Tom McIntyre took this shot of the daytime moon. And again from Tom, the Ring Nebula in Lyra, Messier 57. David McMullen grabbed this shot of Messier 13, which is a globular cluster in Hercules, with his Dwarf 3 smart telescope. And again from David Messier 106 with his Dwarf 3. And I'm amazed by the detail that's coming up here in the arms of this barred spiral galaxy and the dust layer you can see in this small galaxy. Again, for 30 millimeters of aperture, pretty amazing. I think an astronomer from 100 years ago would have a heart attack. You can see what kind of images can be captured with something you can almost fit in your pocket. And that's it for this month.
David, I have a question.
Yeah.
The RASC has the 3 certificates for photography, and deep sky is one of them. Are you allowed to use these smart telescopes?
I don't know. Last time I looked at the criteria, there was no mention of them.
I don't see why you wouldn't be able to.
Yeah.
You go 2 telescopes for it.
That's right.
I suppose,
Yeah.
The challenge is
David, it
finding
seems like almost like a cheat, though.
David,
I had to do it the hard way.
Sure.
Dave, can you repeat the question?
Oh, so the question is from Tony was whether you can use smart telescopes to get images to fulfill the criteria for the DSO imaging certificate. And
most of those images have a chunk of processing done to them.
yeah, all the smart telescopes done for most of them is stacked.
Yeah.
If that.
Yeah, and then they're brought into a computer and
Yeah.
processed. So,
Which is what you would do with a traditional
yeah,
astrophotography setup on a go-to telescope. So yeah. So impressive. Okay. Oh, I didn't see the agenda slide. Why did we miss that? Maybe I missed that. Oh yeah, went through it. Okay, so we've had the welcome introductions, photo montage. So now we have our keynote presentation by Michelle Lane, Tiffany Fields, and Mackenzie Hayduk, Starfinder, the David Lane Astronomy Outreach Program. Then we'll have a social break, and then a presentation by Tony, followed by news from the board and what's up in June. Judy is going to do the introductions.
Thank you. Welcome, everyone. I have the extreme pleasure of introducing our keynote speaker. I'm going to highlight Michelle Lane in particular. I'm going to let her introduce her fellow presenters, Tiffany Field and Mackenzie Hayduk. Did I pronounce it right? Hayduk. Sorry, wrong first letter. And nonetheless, Michelle has been a driving force behind a couple of programs that we've been introduced to over the past couple of years. One of them was the Scope Fund, And the other one was certainly this one, the Starfinder program. It's been an interesting trip for her and the team to build this program and to inspire youngsters to learn about the night sky and to involve the teachers of the province in this project so that it's part of the curriculum. So I don't know much about the program, but I'm really excited to learn about it. So without further ado, I'd like to introduce and have you welcome Michelle Lane. You can sit down now.
Flip it on?
Yeah.
Is that that?
It's a quick. There we go.
Lovely. Thank you. Hello, everyone. I'm delighted to be here with you today. And I have a number of folks who are going to join me momentarily, and we'll speak about them at the very end. Many of you, of course, in this room knew my husband very well. And those who didn't know him personally have probably heard of him over the years, about the incredible accomplishments he had in his life of astronomy, his career here at St. Mary's, his contributions to RASC, but probably most of all, his passion for public education and outreach and engaging with young people to inspire their love of the stars. And so when he was diagnosed 3 years ago with an incurable cancer, it was actually very early on that his first wish was to find a way to keep that work going. This is where I always tear up, so bear with me. So we started to talk about, well, what could that be? What would that look like, and how could that come to be and live on as an enduring legacy? We had many, many conversations as we dreamed and schemed about that. And then we began the conversations with the folks at St. Mary's, where he had spent 29 years of his career and had been exposed to it long before because of his fascination with astronomy. And as we began to work with some of the people you're going to meet today, Tiffany Fields, you know well. Tiffany's over here. You're going to meet by Zoom also with an incredible member of the team, Andrea MIsner, who is, of course, well known to many of you in this room as a member of RASC. And you're going to hear in a little bit from Ben O'Toole, who's actually a participant in the program and now a member of RASC. I'm also delighted that a few other members of the team are here, and that's Mackenzie Hayduk and a recent joinee, Kyla Saylor, who are all part of this program that emerged as Dave and I began to talk with St. Mary's about what public education and outreach could look like as an enduring program. And what emerged was the Starfinder, the David Lane Astronomy Outreach Program that is now up and running and beginning to thrive and will live on in perpetuity. You're going to get a sense today of just a small taste of what that program is all about, a little bit of the ways that the team engages with teachers. But I also want to talk to you very briefly about what was really at the core of the program, and that's the focus of it. And of course, as astronomers, you know all about the importance of focus. And from the very beginning, when Dave and I began to talk about this, it was fundamental to him that if this program was really going to be magical, it had to start where it had started for him with his teacher, and in fact, in particular, with his grade 11 astronomy teacher. He's no longer living, Wilf Morley, but he lived large in Dave's life, and we talked about him often because Wilf Morley, ironically from Parkview Education, where Ben now teaches, was the person who not only helped fuel the spark that already existed in Dave, but he helped Dave bring it to life with foundational skills in astronomy. As a young boy, Dave began his fascination with the stars, he told me, when he was given these two little hardcover books. And he read them so often. One was about the stars, one was about space travel. He said he read them so often that the covers fell off, but he kept reading them anyway. And when he got to Parkview, Wilf Morley brought astronomy into the classroom, but he didn't just bring it to the classroom, he brought it to life for his students and the astronomy club, of which Dave was a very keen member. And they had field trips, they went stargazing, they came to SMU. Dave first met the Burke Gaffney Observatory that way. And that lifelong love and expertise in astronomy started there, fueled by the teacher and that one key connection between Dave and Wilf Morley. So when we began to talk about Starfinder and began to talk with St. Mary's about building a program like that that would endure, it was pivotal that it begin with and revolve around teachers, ideally even be designed with and for teachers, as it was, and that it find a way to bring astronomy to life, to be fun, and to foster that spark and that love that would not only fuel an interest in astronomy, but in so much more in life, whether people ever pursued careers in science, but to spark that sense of wonder and curiosity in life itself, which had been so pivotal in Dave's life. The Starfinder program, which is now entering its second year, started with curriculum hardwired to grade 9. It will move on eventually to build connections for grade 6, because those are the 2 years in Nova Scotia where astronomy lives in curriculum. And Dave knew from all of his work in the schools that when astronomy gets connected to curriculum, it's relevant and accessible for teachers, because that's what they're there to teach. And so finding ways to bring that curriculum to life, to make it easy, to make it fun, is really in part what Starfinder sets out to do. We envisioned, Dave and I, a program that would live in perpetuity, and so set up a significant endowment to help ensure that. I am delighted to be able to continue my involvement with St. Mary's, and will do so for as long as it's feasible to be an advocate and a champion for the program, and in encouraging others to support it. I'm delighted to acknowledge that many of you actually in this room have generously supported the Starfinder endowment as well, and I thank you for that. As you're going to hear from the team today, this program is about sparking an interest. Sparking an interest in astronomy for that next generation, the generation that may well be the future of this club. And so it's a delicious alignment, actually, that Tony is going to follow us and speak about a new program that you've been building and are connecting to star parties and to outreach, because I think all of those programs and initiatives are so incredibly valuable today. And I know that public education and outreach is really at the heart of what so many of you do in the room, because when I see the notices about a session being held at a parking lot or at SMU, I know many of you answer the call to be there to help out. Each of those programs really sits at the heart of what mattered to Dave and what we dreamed about in building the Starfinder. So I'm really thrilled that we have this chance to share it with you today. And I know that some of you, because of your support for people like Ben, who are bringing this into classrooms, are already helping with education, with equipment as well. And all of that makes such a wonderful difference. So thank you for your interest today. And I'm going to now invite Tiffany to lead us in the next stage of the program. Thanks, Tiffany. Of course. Otherwise, you might hear me muttering back in back in the row. Thank you.
Perfect. All right, I'm gonna get us set up here so I can use this guy. I'm gonna try. Well, let me know if you only hear my hair, because you might. All right, thank you so much for starting us off. It's incredible to hear about your Dave's dream, and I hope to take you through what we've done so far with the Starfinder program. So I'm going to start us off just by introducing the folks that are working on the Starfinder program right now. So we've got Andrea MIsner, a teacher out in Winnipeg who has been an incredible help in building those lesson plans. She was awarded the Prime Minister's Award for teaching last year or the year before, and she's an incredible teacher. We have Kyla Seiler, Mackenzie, Hayduk, who are actually in the room here and going to help out a little bit. Mackenzie is going into her third year of the astrophysics program at SMU. Kyla just graduated from the astrophysics program at SMU, like last week. And so they've been helping out a bunch. Myself, I'm the astronomy technician here at St. Mary's University. I run the Burt-Gaffney Observatory. And we have Dr. Vincent Hainault-Brunet, who is the director of the Burt-Gaffney Observatory, and he's one of the professors in the Department of Astronomy and Physics at St. Mary's. And so we've all had a big role to play in getting this program running. And I want to start off with something fun. So a big part of the Starfinder program is inspiring and engaging students, and so this is what I hope to do with you. Yes, thank you. So I want us to talk about exoplanets, which is one of the subjects of one of the lesson plans that we've got. And I thought that this would be fun, so I don't have any prizes. But the goal here is when I give you one of the questions, yell out your answers, or if you're online, type them into the chat, and we will see how we do for bragging rights. But the first one, I'm going to answer for you. Can you click on the slide again so I can click it? Yes, okay, the first one. Let's define what an exoplanet is. So an exoplanet is a planet that is outside of our solar system. It's a planet that orbits around another star. So I'm going to go right into it. First question. How many confirmed exoplanets are there?
6,000, yeah.
If we're doing Price is Right, 6,400 is not correct.
399.
I heard 6,000. We've got a little bit above 6,000. Into the chat, we've got more than 9,000. Right now, as of 2 days ago, there are, I don't remember what the last digit is, 6,298, I think, confirmed exoplanets.
Yeah.
Put it right below the little, yeah, that guy. Yeah, there we go. Okay. 6,298 confirmed exoplanets. And this was updated. So I started the slides a couple of weeks ago. And then I had Mackenzie actually double check all of my answers. And she's like, actually, that number for the exoplanets is wrong. Truly, they get updated all of the time. But there are thousands more candidate exoplanets where we are just waiting for more data. All right, so that was the first one. We had a few nearly correct answers there. Very good. Oh, you'll have to click just on the slide for me again. Thank you for all of your technical help. All right, question 2. What is the name of the telescope that provided data to discover more than 3,000 exoplanets? Kepler. Tess was also in the chat. Kepler, that's my dog. One of my dogs is named Kepler, but this is actually Kepler. The Kepler Space Telescope. It was looking at one part of the sky for 10 years, and its whole job was to discover exoplanets using the transit method. It did a very good job. There's still thousands of candidate exoplanets, and I'm sure that astronomers will continue to find interesting things in the Kepler data, despite Kepler no longer reporting data back to us. Okay, question 2 of 4. Let's go to question 3. How far away is the closest exoplanet to our solar system? I hear a lot of whispers. 4-point-ish light years. Yeah. The nearest exoplanet to our solar system is actually around the nearest star to our solar system. So like 4.2-ish is what I found, but 4.3, sure. Light years around Proxima Centauri. I have some notes there because I thought it was interesting when I was finding this out. There's 2 confirmed exoplanets around Proxima Centauri and a 3rd candidate exoplanet. And then, so like with Proxima Centauri, there's like 3 stars right in that group there. So it's Alpha Centauri A, Alpha Centauri B, and then Alpha Centauri C, I believe, is Proxima Centauri is the closest one. Alpha Centauri A has 1 candidate exoplanet, and Alpha Centauri B has no known exoplanets. But indeed, the closest star to our sun has known planets around it. That's incredible. 4-4, last one. What's the name of the first exoplanet discovered around a sun-like star? That's not what I had. Who else wants to guess? Oh, I see. It's from Project Hail Mary. I just watched that. 51 Pegasus. We've got it in the chat. Who was that? Oh, I can't see the name anymore. Incredible. That's what it was. So the first exoplanet discovered around a sun-like star was 51 Pegasi b. There were a couple of confirmed exoplanets around, like, pulsars before then, which that's weird and was unexpected to find. But the first one around a sun-like star, confirmed in 1995, so just over 30 years ago, 51 Pegasi b. So we try to get students involved. You know, we try to get people excited and engaged and comfortable and welcome and in what's going on with astronomy. So now for something different, but similar. Mackenzie and Kyla are going to help me pass out some materials for this next activity that I'm going to make you all do. Oh, but first I should introduce this. So earlier this week, Mackenzie, Kyla, and I were at J.L. Ilsley High School for 2 different days. We did 5 different classroom presentations for grade 9 science, where we essentially went through like an exoplanet presentation to like assist the teachers in their astronomy section of the year, which is often comes at like the very end of the years when teachers will eventually get to the astronomy section. So they have this space exploration section, so we came and we chatted about exoplanets. So this was one of the slides that I showed them, where we talked about the Burt Gaffney Observatory. And at this point, I'm all done with the chat, but let me know if questions come in. So we'll slide that away. Okay, cool, thank you. So the Burt Gaffney Observatory, I'm not going to talk about it very much, but just note that it's here on SMU campus. We've got a 24-inch diameter telescope here at SMU, and we use this telescope to look at dim and distant objects that are out in the sky. So our telescope is very special, and I'm biased in saying that, right, because I run the telescope, but our telescope is special because it's a robot, and anybody in the world can ask it to take images for them. So things like students in classrooms can have our telescope take images for them. They can talk to it over email or text messages is what I would recommend for classrooms. And it's relevant here because the Burt Gaffney Observatory here in Halifax on the ground can observe exoplanet transits around distant stars. And that's really neat to be able to see our own exoplanet transit data from here in Halifax. And there's a lot of cool things that you can learn about an exoplanet given its transit data. So I'm going to make you do an activity that I also had the students do, except it's going to be harder for you. So Kyla and Mackenzie are going to pass out a pack of 5 exoplanet light curves. And if you're online, I recommend you take a screenshot of the screen and then just like look at the images when we get to the next slides. So you're going to work in groups of, like, there's not that many individuals here. So we're going to work in like groups of like 1 or 2 or 3 to sort these light curves in a couple of ways. So I'll let Kyla and Mackenzie pass those out. And everybody should have 5 different exoplanet light curves.
Are 5 each? Oh.
Yes, 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 5 each. 5 each. And like, if I had more time to prep, I would have put paper clips around each of the 5, and I didn't. I printed these out like an hour ago. So for the folks online, you can grab a screenshot, have a look at it there. Did everybody or like every group of like 2 or 3 people get a set of 5 exoplanets? We've got some extras. Make sure you've got 5 different names. All right, so there's names on the top, right? There's titles here. And some of them are similar, but make sure you've got 5 different ones. And if you don't...
Give us one of your 270s.
Do you want to pass one? Best of luck.
Can't quite get there from here.
All right, we'll make sure everybody gets one.
Get one? Oh, you did.
In just a moment, I'll tell you what your task is. All right. I think we've got everybody at this point. Okay, so your first task, there's going to be 2 tasks. Your first one is I want you to sort the light curves so that the slowest exoplanet transit is on the top and the fastest exoplanet transit is on the bottom. And I'm not giving you any other background information, so best of luck. Do your best. Put the slowest on the top, put the fastest exoplanet transit on the bottom. Do you? Yeah. Oh no. Oh yes, you do. Do we have any extras? We need the TOI one. Thank you. We'll blame. There we go. So there's the extra. Yeah. That's okay. We've got at least one group that's done. I still hear lots of chattering, so we're going to give them a moment. All right, there's still a lot of chattering happening. How's that sorting going? Yeah. So all of these exoplanet transits are from data at the Berg-Gaffney Observatory. All right, I feel like I've got everybody's attention here. So this is what I had for answers. Does this agree with what you had? Would you like to argue with me? You're welcome to. Did you do it from fastest to slowest and like have them backwards? So something that I was asking the students earlier this week, and like granted, I had given them lots of background information about this graph, more than I gave you, but something that I was asking the students is, did you use the numbers on the graph or did you just look at their shape? The numbers, thank goodness. So with the graphs, and this is real data from the Berg-Gaffney Observatory. With the graphs, all of them are like made just slightly differently. The same numbers aren't in exactly the same places everywhere, so we can't just look at the shape. We've got to look at the numbers. And so I asked us to sort this from slowest to fastest exoplanet transit. And I notice on the bottom, the x-axis, this says minutes, so it's measuring the time. And this is minutes since transit midpoint. So like the middle is time 0. For this one this exoplanet transit that's in the middle, this one that says WASP 77AB, that's the name of the exoplanet. I notice that the transit starts when the red line, which is our model, starts to dip. So that's at like roughly 60 something-ish. And then over on the other side, the transit ends when we go back up to flat brightness, 100% relative brightness of that star. And that ends at like roughly 60-ish minutes after the midpoint. So 60-ish plus 60-ish. There's roughly 120 minutes of time in there. And so we would compare that with the other exoplanet transits to figure out which one was slowest, which one was fastest. There's a question in the back, yeah. Can you say that again? What's with the B letter at the end of the names? I really like that question. So you'll notice for all of these, it says like the name and it has a lowercase b at the end. The way that exoplanets are named is they take the name of their host star. So for example, WASP 77A. I love how we name things in astronomy. But like the star's name is WASP 77A. The first exoplanet that is found is given the letter B, lowercase b at the end. So it's given the name of the star plus a lowercase b. The second exoplanet that's found around the same star gets a C. And then the third one gets a lowercase d. And it just continues on down the alphabet with lowercase letters at the end. So that's why they all have B at the end, because it's the first confirmed exoplanet around that host star.
Why not A?
Why not A? I have no idea. I think that when exoplanets were originally like starting to be named in the 1990s, I think that they did use like a capital A for the first found exoplanet. And then but then A is the star also if there's like multiple stars in a system. So at some point, the naming of exoplanets changed from like A to start at B, and they're all lowercase. And you would have to consult the International Astronomical Union. It's just how it is. But I like the question. They're also the same people that decided that Pluto was not a planet correctly. That's fine. Yeah.
Are these always symmetrical about the 0 point? And if they're not, does that tell us anything?
So the question was, are these exoplanet transits always symmetrical about the 0 point? And if they aren't, does that tell us something? With the way that this model works, it's mathematically like the timing is moved such that the middle is at 0. We can also look at this data in terms of like absolute time and then just compare if that is exactly the same as what the predicted midpoint was. So I don't remember if it was the model. So I was using the software called Exotic from NASA to do these exoplanet transit reductions, just for those that are interested in the technical bits. And I think that I actually might have taken that data and then changed it into a graph that looked like this. But there would be some midpoint of the transit. And I think the graph was like specifically like, let's find a midpoint and put 0 there. But it could tell you something if the 0 was not exactly in the middle, depending on how the graph was made. I like it. I've got one more task for you with these exoplanet transits. So I want you to take these transits again, these 5 transits, and in your group, sort the light curve so that the smallest exoplanet is on top and the largest exoplanet is at the bottom. These are, of course, relative to their host star size. I recognize there's a bunch of different things that could go into this, but relative to their host star, sort this from smallest to largest exoplanet size. I do have a hint on the board. I'm kind. There is one hint. Sure, you can mark on them. In the room, I can hear people talking about numbers. There's still some good chattering going on. We'll give you another minute or so. Bragging rights.
Okay.
Bragging rights if you get this correct. I didn't bring any prizes. I should have. Your prize is you get to keep the exoplanets. Yeah.
Is this 2 nights worth of observing? Because there seems to be 2 dot lines.
It's just one.
That's only in 1 night.
Yeah. Over like a 3-ish hour period.
Yeah, I got
Yeah.
that, but I'm just surprised that it must be taking maybe some.
Yeah. If the star is pretty bright, yeah.
Because you said the numbers.
Yeah.
Look at the numbers.
Yeah.
We did.
Yeah, that's perfect.
But I mean, you could have eyeballed it.
Could have eyeballed it. I think the important thing is like, how do we interpret graphs?
You want the smallest at the top, is that right?
Yeah, we had smallest at the top. Okay, I'm going to bring it back. So I gave us the first one, which I said was the smallest exoplanet relative to its host star. This, can you click this? There we go. Okay. These are my answers. Again, if you would like to argue with me, you're welcome to. We've got bragging rights for at least a few groups in the room. Amazing. Oh, I like that. Okay. So Mary Lou in the room, just for the people that are online, was mentioning they were looking at, so the depth, they were thinking about like the distance from the star to the exoplanet and the relative size of the exoplanet, and also thinking about exactly how long it took to go to that maximum depth. A lot of things to actually think about there, yeah.
So we figured it's a trick question.
It's not a trick question. It's for grade 9 students. But you're so right. There's truly so much more that is in this data than just like, oh, like which one's biggest, which one's smallest. But if we do break it down into like more digestible chunks, it's thinking, okay, how can we actually read these graphs and how can we get real correct information out of these graphs on like a general level when you're just starting to learn what graphs look like. And so here I want to explain how I came about my answers, and I sort of explained it in the text way up at the top. But say for the one, I'm going to use the one at the bottom, even though it's super hard for everybody in the room to see. But the one that was the largest relative to its host planet was WASP 10b. And so I looked at how deep the red line went from that 100% line, and I saw that it went to about 97%. So that means this exoplanet blocked about 3% of that star's light. And that 3% was the most of all of the 5 stars. However, something that is tricky, because this is real data and these are all graphs, is that like this one, this Qatar 1b, the graph looks like it has a deeper dip just because of the way that the graph is made. But if you look at the numbers, it goes down to about 97.5%, so only about 2.5% of the star's light is blocked. So again, like we use the numbers and not just what the graph looks like. I saw one hand here.
So when we say these graphs are measuring the amount of light that the sun or the stars are reduced by.
Yeah.
The size of the planet.
Yes. So definitely, technically, this is the amount of light that is being blocked by the exoplanet going in front of the host star. Absolutely. There's a whole bunch of simplifications that we say when we're like, oh, like let's look at the size of the planet relative to the star. But you're right, it's just the amount of light that's blocked from the exoplanet. Let's go over here.
Tiffany, when you're looking at this data, does one usually do statistical analysis? Because if you look at the variation,
Yeah.
you did a standard deviation there. There's a lot of overlap, so there's probably no real statistical difference.
So David Hoskin in the audience is saying, like, okay, well, if we look at all of these data, there's a lot of variation in these data points. Like, there's probably no real statistical variation here, maybe. But like, yes, when the data is reduced, especially through like this pipeline that NASA has put out, like there's more that goes into it. There's more that goes into it for sure.
Those are model fits as well. They're not curve fits.
So in the room, we've said these are model fits as well, not curve fits. And I trust whatever you're saying. because I don't remember exactly everything that goes into getting those curves.
Doing the same thing.
Yeah.
You won't find those if you find a new exoplanet
Right.
because there's no model yet.
So the model is not, the red curve is not specific to this specific exoplanet. It is specific to exoplanet shapes, but like the model doesn't need to know exactly what exoplanet this is to get the fitter doesn't need to know what exoplanet it is to get the model. But indeed, we were able to, use the data reduction to grab some sort of graphs. What was that?
I said it's a neat website they have.
It is a neat website that they've got to be able to do this for sure. It's really, really useful. I'm going to go in the back first. So why is it that after we get to where it's transitioned that it continues to dip a little bit? Shouldn't it just be flat? It probably has to do with stellar atmospheres and like limb darkening of the star, where the outer edges of the star aren't giving off as much light as the middle of the star is. Probably is a combination of a variety of things that I don't expect grade 9 students to know. But yeah, it's a really good question. I'm going to go in back and then we'll come back in front. Yeah.
Yeah, but it must. This is kind of applied to small photometer, like a really sensitive photometer. It must be really small amounts of light that it can detect like that.
Yeah, so the question is like, are we using a very sensitive like camera essentially? Like it has to be a very small amount of light that we're getting. We're actually, this data is from a second-year university project that gets done in our astrophysics program, actually, where we have the second-year students go out to a website where you can find known exoplanet transits and like transits that are going to be happening on specific nights. And we focus primarily on bright enough stars where their exoplanets block more than 1% of their overall light. And we just use like the CCD that's on the Burt-Gaffney Observatory. So it's like, yeah, our CCD is like a fancy piece of equipment, but it's just a camera. Blair McDonald has done exoplanet transits with the cameras that you've got.
Telescope, 120 millimeter scope and a commercial CCD camera. You can get exoplanet transits.
Yeah, so Blair's saying,
At least down to 10%.
yeah, that you don't really need a big telescope because some of these known transitors
The stars are quite bright. Right?
are around very, relatively speaking, bright stars that even with a small telescope and a plain like regular CCD, you can get transits that block like 2.5% or more. Other questions before I go on? Yes, Mary Lou.
Were these all solar class stars, or are they all different?
I don't know. So we're asked, are these all solar class stars? So like thinking about like size or spectral type. I honestly, I don't know. I would have to look. I'm not sure.
The basic way to determine the mass of the planet is to know the spectral classification of the star, so you kind of got an idea of the mass of the star.
Do we do that?
And you're using Newtonian physics then to determine the mass of the planet, right?
Yeah, so you can use a spectral class of the star to figure out like how big it must be, to figure out how big the exoplanet must be exactly. When we like get into the lesson plan booklet here, we do introduce the teachers into like a little bit of math where if we give them the radius of the star, they can like figure out what the radius of the planet would be. But we don't go like too deep into it because we want to like introduce fun astronomy things and we don't need to get like super into the woods about it depending on like what the subject is that we're getting into. But yeah.
Spectral data for any of those?
I do not have spectral data for any of them.
Even color camera data?
No, all of these were taken Yes, yes, yes. They were all monochromatic. Yeah, ask me a question. I love that you asked that. Okay, so the question was, can I ask you a question a grade 9 student would ask you, and is there life on these planets?
42.
They are all smiles. No, I love that we asked that question because that's actually what I spent like 20 minutes of the presentations that I was doing earlier this week chatting about with students, just to like have a discussion about could there be life in the universe. I don't think that, well, I mean, okay, as an astronomer with a little bit of extra background knowledge, what I see from these light curves is their transits are very fast. They must be moving very quickly around their host star. They're probably very close to their host stars. What I also know about these, just from knowing some more background information, is that they transit their star roughly every few days. So I think that they're just probably too close to their host stars, these ones in particular, to have life on them. But there's so much fun discussion that you can get into with students about could there be life elsewhere? What do we have on Earth that makes life possible? What would we need to find elsewhere? What if you left the Earth and looked back and tried to prove that there was life here? Like, what would you need? What could you use? And in our lesson plan for exoplanets, we sort of start off the lesson by like using this really interesting thing that we're trying to find in astronomy, like, are we alone in the universe? And that question, like, could there be life elsewhere, to sort of motivate getting into exoplanets in general. Great question. I noticed in the chat as well, there's the question just about the process here. Why use exotic instead of AstroImageJ? We did use AstroImageJ, which is another modeling tool for many years. It's finicky software. It is just that, like, the students ended up having a lot of problems with it. So it's also great. We've also used it. We used exotic for like the first time in the last semester, and pros and cons to both. It was just a different piece of software that I thought would be a little bit less finicky for all of the students' laptops. We can take maybe another couple of questions or so about this particular activity, and then I'll continue on with what else we're doing with Starfinder, because I love this. This is like how we're engaging students, right? Let's go up here first.
Well, going by what you say here about the smallest, what is the largest known percentage of light blocked from the parent star?
Ooh, what's the largest known percentage light blocked from the host star of an exoplanet? I don't know. I'm not sure. Can we count a solar eclipse? I don't make the rules. Yeah, 100%? Is it 30% or so? Oh, Tabby star? Oh, 33% Tabby star. Wow. Oh, I see. Okay. 30%, that's crazy. Thank you. Solar eclipse was a great answer also. I saw like one more hand over here, yeah.
In terms of the speed of transit, can you tell what's going across the middle of the star versus, maybe just towards the top of it?
Yeah, I don't have a great answer. So, okay, the question was, in terms of the speed of a transit, or like looking at a transit in general, how can you tell if it's going across the middle of a star or like across the upper portion or like the lower portion from our line of sight? I don't have a great answer, honestly, for how can we tell that in the data. The exoplanets that we look at, like, inclination is generally a bit of the data that's available for every single exoplanet. I don't have a good answer, though. I'm sure there's a way. Yeah, so Mackenzie's saying, like, maybe we can figure out a little bit from how flat the light curve is at the bottom. We've got another comment. But Tabby star is an exoplanet. I think, so up on the comment there, I think that the implication was that there is an exoplanet around Tabby star that blocks a significant part of the light, is what we were mentioning there. Somebody can look it up. I love what we did there, right? So I grabbed your attention with some trivia, right? And then I forced you all to participate in an activity. Mary Lou and Blair are still having a discussion over there. So I forced you to do an activity with some real data. We learned about how to read graphs. And then we had like this big discussion about all of these other questions that we had related to exoplanets or life or like the intricacies of modeling exoplanets or looking at data and all of those things, which is like what we hope to inspire teachers to be able to do and what we hope are things that like classrooms will be able to do as well.
Tiffany, one other thing the students can do if they have access to color camera data.
Yeah.
They can get a pretty good idea of whether the planet has an atmosphere or not.
Oh, I like that. So we mentioned up at the front here, if students have access to color data from an exoplanet, they can get an idea of whether that exoplanet has an atmosphere or not. And like that is totally something that's possible for us to do with the Burt Gaffney Observatory. We have a variety of color filters that are available. So that's, Mackenzie and Kyla are taking notes for me. Thank you. Which would be easy with a color camera because all of our data would be taken simultaneously. I was thinking like, oh, these exoplanets transit every few days. We would be able to do like one in one color, but I think a color camera would actually make a lot more sense, yeah. Oh, it's not that fast.
No,
well,
if you have color camera data, it's relatively easy.
I like that.
You just look at the difference between the blue curve and the red curve.
Yeah, so looking at the difference between the blue curve and the red curve to look at if the exoplanet would have an atmosphere. Yeah, that would be really cool. That would be really cool. Jerry, can I have you click on my slides? And I'm going to go to the next one. You might have to get rid of the chat box, but let me know if there are questions that come in. Click on my... There we go. Okay. And so this slide here is, well, I would have given the information to the grade 9s in like 3 or 4 slides, but this is a condensed version of what I presented to the grade 9 students earlier this week before I made them do the sorting activity to show them all of the different pieces of things that we find on this graph. So I talked about what we have on the x-axis, how time is increasing off to the right, and we're measuring that in minutes. We have the amount of light, the relative flux, the amount of light, the amount of brightness, sorry, from the host star. The black dots are all of the actual data points. For this exoplanet transit, images were taken every 30 seconds. And then from those images, we measured the brightness of that star in the image and we plopped it onto this graph. The red line is our best fitting model. And from that model, we can learn about this exoplanet that we're observing. And then I pointed out to them this green line that shows us the change in brightness from 100% down to the bottom of the curve. And then we went off to the side and we said, oh, that's about 97.5%. That means about 2.5% is blocked. And then we also looked at the duration of the transit from where it starts to dip to where it ends the dip. So just continuing to show some of the things that I did show some grade 9 students earlier this week and that we outline in this lesson plan that we have about exoplanets. So I'm going to keep going. Okay, so I made us all do that activity. I feel like we have a pretty decent idea of like what the Starfinder program is, but to sort of talk about it a little bit more in depth, we are in our 2nd year, but we're a new educational program at St. Mary's University to enable teachers across Nova Scotia to deliver an astronomy-focused curriculum to their students. We have focused first on grade 9, where space exploration is in the curriculum. We'll focus later on grade 6, and we'll continue to build out from there. There's a lot of other connections that we can make to, say, mathematics and more in the curriculum. We really want to foster enthusiasm from the students. We want to get their engagement and help their understanding of astronomy. And we want to help their teachers do that. We have an emphasis as well on engaging rural Nova Scotia and underserved communities. So not just like those that we can directly reach here in Halifax, but an emphasis on trying to reach the whole province. We're absolutely continuing to share Dave's legacy of his passion for outreach and sharing the sky with as many people as he could. And we share the Burt Gaffney Observatory's robotic interface with those classrooms, and also the extensive image archive that we have. So the telescope has been available for use online for about 11 years now. There's almost 30,000 images that are available online that we can also use in addition to the students using the telescope themselves. We've done a lot so far. And just in this first year and a bit that we've done. So with Andrea MIsner's help, we've developed a whole book, and I've got a couple of copies here if you want to poke through them during the break. We've developed a whole book of lesson plans and a list of online resources for teachers. Andrea MIsner did an incredible job, truly like leading the effort to build those lesson plans. We hosted a workshop last August here at SMU. It was a 2-day workshop where we invited teachers in for free. We gave them lunch, lots of snacks, to go over everything that we had made, to teach the teachers what we had done so far. We had 14 teacher attendees last August. We then attended the Association of Science Teachers conference in October. So that's where all of the science teachers in the province come for like a professional development day. It's hosted at Halifax West. So we went there, we had a table where we met hundreds of teachers. We gave out a bunch of t-shirts and we gave out a bunch of printed materials and such. And then we did a presentation to, I think, about 25 or so teachers. Mackenzie and I did a presentation introducing the program and the Burt Gaffney Observatory. We participated at the Halifax Central Library in their like science cafe on a Saturday, where we went with some demonstrations, some printed materials. There was a whole bunch of families with young kids, and the library set up like a styrofoam ball painting station, which was a big hit. It was pretty cool. Like I mentioned, we were at JL Isley High School earlier this week, 5 different classrooms. So we hung out with 5 teachers and their classes. Over the last year or so, we've welcomed a few classrooms from those teachers that have participated in Starfinder Things to come visit the Burt Gaffney Observatory. And we've kept in touch with a number of the teachers, like Ben and more, to provide email support to those teachers, to some students that have been like inspired by Starfinder activities, or if they're trying to use something and have questions, we've kept in touch with them. I've got a QR code on the side that I'll also have at the very end to our like Starfinder resources page that has a copy of this book and like all of the resources that we link to in it. But we've created a lot so far for teachers just in this first year. This booklet, I say booklet, it's a book. It's more than 200 pages. This book that we've made aligns with the grade 9 space exploration unit of the Nova Scotia curriculum. It cross-links to mathematics. It could be used in other grade levels. We have these 8 topics, or like these 8 lesson plans that we've made that go over the basics of sky motion, scaling distances in space, how to digest and understand a scientific article. We go into how to use the Burt Gaffney Observatory for imaging. We connect art and science with some of those Burt Gaffney Observatory images in color. We've got a lesson on lunar exploration. We've got this exoplanet lesson that has some of the stuff that we've just done here. And then we've got a lesson about star clusters as well. There's a lot. There's a lot in there. And there's some photos here of some things that we've done. So on the left side, some photos of our teachers' workshop and the teachers that joined us for that workshop. A photo from the Science Cafe at the Halifax Central Library. There's Mackenzie there with a lamp and an earth and a moon doing a demonstration there. I took one photo over the 2 days in 5 classrooms at JL Isley. I didn't want to take any photos of students, but I got this one photo of the board from this presentation. And then part of the table from the Association of Science Teachers Conference. A keen eye will notice this tablecloth. Some of you in this room will recognize the tablecloth because we borrowed it from you. Thank you. We'll come back to you again in October for that again. So I want to move on here to highlighting some of the teacher experiences. So I'll share first from Derek Avermenko, who is a teacher at Avon High School in Windsor, shared with us that, so this is Derek, this one here. I did not have any good photos of Derek, but we had this one from the workshop last year. He says, the visits to the BGO are always informative, and the students always tell me how much fun and exciting the sessions are. It is great for the students to get some hands-on experience with topics in astronomy. So Derek has had a few classrooms visit the Burt Gaffney Observatory over the last year. I believe he's teaching this year Astronomy 12, and he was one of the teachers that joined us last August and learned about the lesson plans that we're doing. The next teacher that I want to introduce is one that you all know well. And so the next teacher that we have is Andrea MIsner. And so this is where Jerry is going to try to allow Andrea to speak. So Andrea is joining us by Zoom. Andrea is going to share like her inspiration from Starfinder and also the experiences that she and her students have had from the Starfinder program. So what Jerry is doing on the screen. Can you say something, Andrea?
Sure. Can you hear me?
I can hear you.
Too loud? Sorry.
No, you're good. I wonder
really?
if
Okay.
we can eventually see you too, Andrea.
The webcam's on. I don't know. I'm in the I can see
you
myself in the chat.
Close the meeting chat. There we go. And then
Oh, there we go.
And then make her big.
Maybe. So weird. I'm just gonna see Andrea.
If we just
Must be like, I think you have to pull it up and drag the bottom corner down. No, it's dragged as far as it will go. Okay.
Okay.
Perfect. All right, we can see you though. We can see you.
Yeah, you can see me. It's all good.
Take it away.
Okay, thank you very much, Tiffany, and thank you for those lovely introductions. It's been a real just pleasure and privilege being a part of the Starfinder team and getting just getting to know everybody over the past year. It's been exciting to see it take off and exciting to see the impact that it's had on the teachers, but also the students. I mean, I can speak to my own students, but I'll just talk a little bit about like what we saw at the workshop. And I was kind of floored by how many, like, first of all, the teachers who came were awesome, and it was wonderful to see them on. Then it kind of struck me about the lack of resources they really had out there. But also with teaching, there's also a very much lack of time teachers have to implement or learn new things. And even though with the Starfinder kind of feeds, helps with that gap. And even though Starfinder is like a little bit of a learning curve for teachers, it's not huge. So I think it's at a good level right now for grade 9s, and I'm excited to start working on like the grade 6s too. I wanted to talk a little bit about just the impact it's had on my students, because I've kind of thrown Starfinder at them all of a sudden when we first started this and said, students, this is what we're doing, this whole Starfinder team. And I talked about it, told them the background, and they were like, oh, okay. And they were into it. So a lot of the lesson plans were, were kind of hashed out by them, my grade 9s and my astronomy, basically astronomy 11 class. It's open to grades 9 to 12, but it's kind of a mixed bag. So we tested all these lessons out, and it was really cool to see the students like get hands-on tech. In the project we developed, they could choose their own object, and I think that just created some ownership of what they were ownership over their own learning. And instead of just asking them to just take a pretty picture and just talk about facts, I asked them, well, tell us a story. Why did you pick this particular globular cluster? Why did you pick this nebula or this galaxy? Why? And the information I got back by asking my students that was really interesting. They had all kinds of motivations and stories, so it went kind of beyond just interesting facts and information. But they told me they picked certain pictures because of whatever musical bands they were in, or one student took a picture because of a personal cultural connection he had with this particular object. I thought, which was really cool. Just this past year, my students they did a big poster project. One of them, sorry, last year, and they said we felt like little scientists taking an image with a remote telescope. And my other students, this past year, made a big video of the Berggaffney Observatory, and the image they took, they put kind of a little theme to it, and it was really cool because a lot of my students are from the BIPOC community, and looking at them wearing like little scientist shirts they were wearing, and they could see themselves in that role, and they called themselves doctor, and they were interviewing each other, and it was really cool to kind of see that come out of it. So it's been a big push for me too, just within my own classes, and being inspired by it to keep growing and to keep learning, to make those connections.
Yeah. Thanks so much, Andrea.
You're welcome.
And I got to see that video that she mentioned that her students made for one of the images that they had the Berggaffney Observatory take, and it's awesome. It's so cool. And like you mentioned, like seeing them dress up with like lab coats and stuff, and indeed like call each other professor, like that was really special.
Yeah, to see themselves that they could see themselves being represented, and STEM is for them, and they could appreciate it. Yeah, deeper.
Absolutely. Thanks so much, Andrea. Dave Chapman is in the room and wants to say something.
Hi, Andrea.
Hi, Dave.
For those who don't know Andrea, you mentioned she was an award-winning teacher from Winnipeg, but she went to Parkview High, like Dave Lane. She got her undergrad astrophysics degree here at St. Mary's. She was president of the center.
Oh boy.
So that's like a little bit more information about her connection with us.
Mm-hmm.
Yeah. Did we hear all that on the Zoom?
Yes, I did.
So Dave Chapman was saying so much more about Andrea that beyond how I introduced her. So Andrea went to Parkview, got a degree from here at St. Mary's University, was president of this Halifax chapter. Andrea has been so involved here locally. She's currently out in Winnipeg, but Andrea's awesome. We're so lucky to have Andrea on our Starfinder team, and to have her helping out with these lesson plans, but then also testing out all of these lessons and everything. Like you're just so cool. Yeah.
Yeah. Thank
really
you so much. Yeah. You as well.
Thank you. Anything else for Andrea? I think at this point, what I'm going to do is I'll introduce our next teacher. So I'll also see if Jerry can put Andrea away on the screen. Thank you so much.
Welcome.
So we'll make her small. And there we go. Perfect. So the next teacher that I want to introduce, Michelle introduced him earlier. Ben O'Toole was one of the teachers that joined us in August for our teachers workshop last year. He's created an astronomy club with his students out in Bridgewater, and I have the microphone, but I'm going to give you this is yours. Okay, thank you. Yeah. Take it away, Ben. Let's hear it from you.
Okay, so Parkview seems to be playing a big role here. Sorry, that probably hurt. Okay, I'll hold it. So yes, I am a teacher at Parkview, and I also taught Astronomy 12 2 years ago and hope to be teaching it again really soon. This is some photos from the astronomy club that I started this year, which was a bit of a restart because, it has existed in the past. And after doing the Starfinder workshop, I kind of changed my thinking a bit of astronomy because, I'm a big nerd and I want to know all the little details. But for some people, they just want to get out and look through a telescope and have fun. So that's what we do a lot of the time. Here we were taking some shots of a full moon, the harvest moon, as it was rising over the ocean. It was pretty sweet. Here's a shot of us when we were at a campfire during our winter sessions. So usually in our winter sessions we have campfires and take 5-minute break, run to a telescope, get cold, then go back and warm up. The light is a bit of a factor, but we still have fun. And there's a varying, so the club has attracted quite a diverse array of students where some are definitely into astronomy, want to study it potentially as a career, and others are just, they may not even like science class, but they like getting out and seeing the world that they live in, which is, something we tend to forget about sometimes, is that we're all, part of space and that we can all experience it. And you don't need any special information to look through a telescope and appreciate what you're looking at, right? Of course, it helps. And I try to give some of that when we're out observing, like, oh, here, we're looking at this, and this is cool because, it's really old and really far, and like, yeah, but it's pretty colors. So, everyone's in it for different reasons, I guess is what I'm saying. And the club allows people who may not be proficient in sports or some of the other standard school things to be part of a community of students that does something outside of school and really just is a good way for them to be social, right? So it provides a way for those students to find their niche. And in the club, like, of course, we do have some students that are very academically oriented. This lady right here, her name is Mackenzie. She couldn't be with us today, but she's actually going to the University of British Columbia next year to study astronomy. And this is a photo she did from the BGO of a Cepheid variable star. So in the IB physics class at Parkview, in order to get their certificate for completing the IB physics course, they have to do what's called an internal assessment, which is essentially a big project. And for physics, it often involves an experimental component. So she was working with me and Tiffany a bit on her project, which was studying Cepheid variable stars, which are stars that pulsate and contract in their brightness. So I think around 100 years ago, Henrietta Leavitt is the name, discovered by analyzing some of these stars that seem to be, fluctuating in brightness, that there's a relationship between how bright they get and how dim they get and their actual true luminosity, which is not what we see when we look at stars, right? We see apparent luminosity because we're far from them. But the true luminosity is the actual intrinsic brightness of the star. And if we know that from the inverse square law of light, we can figure out how far we are from the star. So Cepheid variable stars help us to determine galactic distances, much like stellar parallax, right? So her project was analyzing the period, so the time between cycles of brightness and less bright. And her star was tricky because it was 4 days. So, you're trying to get 4 days of good images in 4 consecutive nights in Nova Scotia. I'm sure you can relate to the difficulty. But with enough data, and she cross-referenced some other libraries online, she got a pretty good curve, and it's not a sine curve because it's more like it's pretty drastic, the reduction in brightness. It's more like a piecework linear function that goes up and down pretty steep in the curve. But that's some of the ideas of what students could do with astronomy in classes like IB Physics, where you can actually employ some of the tools that you all use in terms of astro imaging. And, I was looking at the exoplanet one and thinking that would make it another great project idea for someone to, maybe use their own equipment to measure, the brightness of a star as exoplanet transits. So I hope to be doing more things like that with some of my students over the years and seeing how we can incorporate actual experiments with real equipment that they can use in their classes, along with continuing the club and having astronomy as a place for people to gather and appreciate the beauty of the universe and have fun. So that's my plan.
It's so nice to hear from you, and to hear what you're doing with your students, and just like how engaged they are and how engaged you are as well. It's awesome to continue to see what you're up to. It was just so nice to hear from Andrea and then to be able to hear from Ben. And it's just like part of the impact that we were hoping to have with Starfinder, and that we are like we're able to connect with teachers across the province. It's just really excellent. Can you click? Thanks. I don't have very much left, so I'm not going to even try to put this back on my sweater. But I want to mention maybe some things that we'll be doing in the future, or like some future looking things. So we have some plans in the near future. For example, we're going to Montreal next week. Mackenzie's leaving tomorrow. I take a flight on Monday. We're presenting a poster at the CASCA conference. So this is the conference for the Canadian Astronomical Society. It's the Astronomy Society in Canada for professional astronomers. We're presenting a poster. This is the poster for Starfinder to share it with the astronomy community. We're also going to be talking to some teachers in Quebec while we're at this conference next week, just to share like what we have available. So we're of course creating this specifically for Nova Scotia, but as long as we're going, we're going to share what we've done. We plan to do another one-day teachers workshop here at SMU in August. So we'll host another event where we are teaching the teachers what we've made so far. We'll again in October attend the Association of Science Teachers conference with a presentation and with a table. We will ask you again for this tablecloth because it's a perfect tablecloth, just as a heads up. And we'll also do a presentation to the Astronomy and Physics department in October this year, just as like the things that are currently on the horizon. We will be moving on to grade 6 specific materials with the Starfinder lesson plans, like Andrea started to mention, in the future as we continue on. There are some other things that we would also like to do. We would like to be able to lead some professional development sessions for teachers, perhaps at their schools. We started to reach out to some schools, just some nearby ones in the last month or so, but I think we realized that this is a terrible time of the year to try to talk to teachers because they're very busy with the end of the year. But so for like the next school year, maybe we can get into some of those PD days and get to teachers directly that way. I think that we would really like to do even more connections with teachers across the province. So like outside of Halifax, more in the rural Nova Scotia areas. Eventually, we plan to translate all of the things that we have into French. That will come. It will come. And we would love to also curate like Indigenous astronomy resources to share with teachers. So I'm thinking like Dave Chapman's Mi'kmaq Moons book, but also a variety of other things. We would like to like curate some resources, maybe pull together what some other people have worked on for teachers as well. I want to go back to something that Michelle talked about when she was introducing all of this. I think the Halifax RASC has a lot to benefit from teachers being more involved with astronomy and with their students being more involved with astronomy. I really do believe that like the young people that are inspired by the Starfinder resources will be the future members of the Halifax RASC. Like this is our local astronomy club. If you're into astronomy, this is where we end up. Um, I really think that getting more like young individuals, teachers, their students into astronomy will lead to even more people showing up to these sorts of things. I think that there could be a lot of benefit for the RASC in general, just with inspiring more individuals to wonder what's up in the sky and to gain a better understanding of astronomy. So this slide and then one more and then I'm done. So directly, how can you help? Like Michelle mentioned, a number of individuals here have donated to the Starfinder program, which is incredible. Donations directly to the program help, but also engaging in us with discussions, like how do you engage with students and teachers? What activities have you found that work really well? What hasn't worked very well with you? And really, we know that members of the Halifax RASC have so many connections. Like you're so knowledgeable about astronomy, you've done so much outreach, you have a lot of experience, and you also have a lot of connections. You've got a lot of people in your circles. If we're able to connect to more teachers or more individuals that are in the school programs through you, that would be so helpful with us. I was able to go visit, well, we were able to go visit JL Ilsley High School earlier this week because I know one of the teachers, or I have a friend that is a friend of one of the teachers there. We had sent the school an email already and they were like, we can't, sorry, nothing, sorry. But like this friend directly reached out to this teacher and they were like, oh yeah, actually that sounds great. Those personal connections help so much. So we would love to be able to get connections from you. So this is sort of how I'll wrap up. I would love for us to continue a discussion, especially during the break time after I'm done talking up here. But we would love to hear from you in general. We've got our email up here. I work here, you know where to find me. But we'll also be around throughout the rest of the meeting to chat with you about anything that you've got in mind. I want to point out some things. I have up at the front, I've got like one-page leaflets about the Starfinder program. These are really nice. They're nice and thick. They feel very nice, but take these, share them with the people that you know. I also have a couple of copies of the lesson plan book that you can look through. If you would like to have your own copy of this book, please let us know and we can print one off for you. We'll do that printing in like August. I can bring them to the September meeting. There's also a QR code that is a little bit blurry on the screen, but like that would give us goes to a form where you can tell us that you would like a book printed, or you can send us an email. And then, yeah, I just have a bunch of stuff up on this table. We would love to hear from you. I'm gonna stop talking. Thank you so much for listening, and thank you to Andrea and to Ben and to Kyla and Mackenzie and to Michelle and everybody for all of their help. And thank you for participating. All right.
Thanks so much. All I can say is, wow, I wish I was young now instead of when I was young, because we never had any of this when we were in school. So this is really cool. So thank you to Michelle and Dave for inspiring this program, to Ben who's implementing it, and to those of you that were involved in the development. It was absolutely amazing. So thank you. At this point, we will have a brief break for 15 minutes. So at 35, 40, 50, 55, 355, 255, sorry. we'll have 15 more minutes, and then we'll come back with our next presentation. So as Tiffany suggested, if you have questions, further questions, please come down and talk to her. I also want to note to people in the room, Roy Bishop's books are here. So if you have an interest in any of his library, have a boo, and please take what you like. See you in 15. Yes, I'm having one of those days where I'm having fun introducing two sets of speakers that are both very phenomenal. So I'm really excited to introduce Tony Schellinck. For many of you who know Tony, you know his history with the RASC. Tony's a longtime member. I first became aware of Tony back in September 2013 at my very first star party, and I blame him for me standing here today with his binocular table. And Doc Binoc, actually, is what we used to refer to him as, because anything binocular related he knew about. So consequent to the 2025 star party, 25? Yes, this is 26. So 25, following our progression of going from sky tour to binocular table to telescopes, we sat down along with Peter Hurley and discussed what kind of a program could we develop so that not only our center, but others as well could use it. And that's where I'm going to leave it, and I'll leave it to Tony to describe what the outcome of that discussion has been. Thanks, Tony.
You're welcome. Okay, apparently I have control.
Yes, he does.
Yeah, the mic, is it working for the folks on Zoom? Okay. And the rest of you have to just listen to my voice. Can you hear me back there? Okay, good. So we did this program, and it was a beta version, and we learned a lot. And so this year, I said we need to be more coordinated, and there's room for improving the program. And so I have been working for the last couple of days on this presentation, and in the process, changing the program quite a bit, actually. But the basics are the same. So this works with Nova East quite well, because we usually get about 20 participants from the campground to come up. At the end, I'd like to discuss maybe whether we could do something at the Dark Sky Weekend similarly. We'll have to have that discussion. And it has 4 stages. First stage, naked eye observation of constellations in the night sky. And this year, Chris Young's going to be doing that. Introduction to asterisms to help find objects in the night sky. And the use of binoculars to observe those objects. It's the second stage. Telescope views of objects in the night sky. And for doing that, what we're talking about is setting up 6 stations, and we'll have to mark them out in some way so people can find them. And and each of those will be looking at a different type of deep sky object. And while they're doing that, several people have the ability to show what they're looking at using displays. And so that's the 4th stage, is where they see enhanced images produced live using these displays. One thing I was thinking of adding to this, as I'm remembering, was the use a handout sheet with printed on both sides, which will have a 1-paragraph description of all the objects that we're looking at, so that people can walk away with that and say, I saw this. And if they don't understand what the person was telling them, they can refer back to this. So that would be part of the program. So now, for those of you who've gone to Nova East, you know that we usually have a deadline that no pointing lasers in the sky or torches or anything like that after a certain time. And it depends what time of year we're doing this. But there is a time constraint here. If we're going to do this program, we have to do it fairly quickly. And so what I've said is 30 minutes for the naked eye tour, 30 minutes for the binoculars, and then 45 minutes, I believe, for the telescope. And after that, we sort of shut the program down. So the original concept was that from the naked eye tour to the binocular to the telescope, we would have the same objects as much as possible. There's a caveat to that now, which I'll get to in a little bit. We're going to keep the number of targets down, but it says 6 or 7, but what we're really talking about is there's going to be 6 categories or types of deep sky objects that people are going to be able to see, and I'm going to go over them in a few minutes. And so it's educational in that sense that we're going to show them that there are these different types of objects that are in the night sky. And this is different from what I do at the Dark Sky Weekend, where I just show people a lot of deep sky objects. So we're going to select targets for each type of DSO. There's 6 of them. Select targets we know the novice observers can find and recognize. So I'm picking objects in the sky that are close to an asterism where they can look at it and say, I can find that and I can see it. Also, I'm trying to make it so that if we look at an object, that when they go to look at the telescopes, they'll see the same telescope or same object through the telescope, and not all the DSOs lend themselves to being produced on a display screen, you know. So I mean, galaxies are a good example of one that shows well on a display screen, but a double star is very boring on a display screen. So not everything is suitable for display. And it's very sensitive to time of year, what we see. Now, the beautiful thing is that all the various types of DSOs are available to be seen in mid-August. It's the only time of year that happens, as far as I can tell. So we're very lucky that way. Feel free to ask questions and make suggestions as we go here. So why this program? It mirrors the steps many novice amateur astronomers may go through. So the first step would be that people just start to look at the sky. It's a big step to go from there to learning about the sky and what's there, and another step to looking through telescopes and that sort of thing. Demonstrates the level of detail to be seen at each level of observing. So you can see 10 times as much through binoculars as you can with the naked eye. And this is one thing that goes when they go from observing through Chris's talk to my binoculars. They're going to be looking at the same places, but they're going to see a lot more. Then when we go from binoculars to telescope, again, they can see a lot more. And that's a good thing to understand. It achieves public education and outreach and education. So I heard a quote years ago when somebody says, don't waste your time telling people about what they're looking at. Just show it to them through your telescope. And that was their concept of outreach. Well, I mean, a lot of people think that way and still act that way, but I'm trying to get everybody that's involved in this process to be more education-oriented, teaching people about what they're looking at, that sort of thing. So this program's designed to do that. We're talking about, with spotters and people put on the program and the telescopes, we're talking upwards of 10 to 12 people who are involved in this program. So last year, we had stage 1, where Chris Young, and he's going to do it again this year, gave a tour of our night sky. And I'm calling it First Nations Stories. Is that right? Is that what you're doing?
Yes, I try and give some star lore, and I usually avoid the Greeks.
Yes, you do. You leave it to me to. Is that what we call it? Because that applies everywhere.
Can you repeat the answer?
He said yes. Yes, he does. He will. He does tell stories, but he doesn't do the Greek stories. Okay. Secondly, after his talk, he then, with his spotter, say, okay, follow me. We're going to go over to the binocular table. And that's where I and Peter Hurley and, was anyone else there? Were you there, Judy? Judy was there too. And you know, when you're pointing a laser at the sky these days, you have to have a spotter watching for airplanes flying around, and that helps. And yeah, and so the two of us, or the three of us, and so we, that's us down here, and the 20 or so people were around, but I show up, as you'll see, with 20 pairs of binoculars, and I hand them out to people. And so I give them, well, I'll tell you in a minute what I do, but so that's the binocular table. After that, they then say, okay, they're encouraged to go over to look at where the telescopes are. And what did we put lights on them last year or something so they could find them?
Glow sticks.
What?
Glow sticks.
Glow sticks, that's right. So they'll have glow sticks on them so people can see, oh yeah, that's one of the telescopes I'm supposed to see. And so that was stage 3, and you can see here Judy's showing some people something. And then over here we have David Hoskins, and he's got electronic assisted astronomy on. What was your setup, David, that time? Yeah, so that's all it took. The 6-inch reflector, laptop, and a camera. So and he and I have given pop-ups at Kejimkjuik, and right, Dave? Yeah, yeah, so it works really well. And if the sky clouds over, people don't care. They're so interested in what David has on his screen that they just stand around and look at it. It works very well. Okay, this is what the sky is going to look like August 11th at 10 o'clock at night. So you can see that a lot of our targets are out there. I'm going to go. Now, I'm assuming not everybody in this room is familiar with all of the targets I'm going to talk about. So for the rest of you, try and stay awake, okay? Here we are. This is the binocular table. So you can see here, I have 20 pair of binoculars, and the reason they're undercover is because they will do over quite quickly that time of year. And so I warn people about that, and then I have handouts I usually give. So this is the binocular table. And it got started at Kejimkjuik National Park. We've been doing this, I don't know, 16 years now. First with David and then with Peter. And yeah, so I'm going to show people just a little aside. When I was putting this together, I suddenly realized, looking at this woman, do you notice anything funny about her binoculars? Yeah, and one of them has the cover still on it, the eyepiece cover. So, I mean, I tell my students when I'm teaching about binoculars, the first thing you do is check to take off your covers. And they all laugh at me. Well, why would we not? No, look, there she is. She didn't even notice. Anyway, small aside. So I started off and I said, okay, I'm going to make a connection. And I'm going to say, here are the targets that I'm going to talk about. I'll do that more in a minute. And then I said, if these are the targets, then they need to know something about the sky around those targets. And we're not talking constellations. We're mostly talking asterisms. So I had this, and I'm telling you right now, so you don't get too invested in this, it's wrong, okay? I'm just showing you the path I took. And I said, I'm going to make these connections, I'm going to make these connections, I'm going to make these connections. And if I'm going to do that, then I said, all right, here's what Chris would have to cover. He'd have to cover this, and then these three averted vision targets. And I looked at that and I said, my God, that'll be boring. There's that's the most disinteresting thing in the world. Why would anyone want to hear a sky tour of that? That's no good. And Chris does such a better job of what he does. I said to myself, I mean, when I give a sky tour, I go Greek. And I tell them all about, Perseus and Andromeda and Orion and all that kind of, the stories, and we've known this for 3,000 years, are what make people understand what's in the sky and help remember the shapes and what's what. So this doesn't work. So I said, okay, I'm not going to do that. And besides, I cover all of these asterisms anyway when I give my talk. So Chris doesn't have to do that. So I said, Chris will do what Chris wants to do because he does it well, and I will do this part. But if I'm going to do this part, I can't. And Dark Sky Weekend, I will cover 12 to 15 deep sky objects with these people. And that's what I did the first 2 nights at Nova East. And that's why it took me 45 minutes to do it, because I was doing all these stars. Well, I don't have to do that. And so I realized what I want to do, what did I just do? I broke it. There we go. What I realized what I wanted to do was there are 6 categories here: double stars, asterisms, galaxies, open cluster, globular clusters, nebula. Why don't I show the participants one of each of those? Because they're in the sky. And that way I don't waste time on another anywhere from 8 to 10 other objects, and I get it down to 30 minutes. So we'll let Chris do what he does. I'm going to talk about these asterisms. It is disappearing. How come? Not interesting. These asterisms and making the connection to these binocular views. So which targets I actually use may vary. And I'd be happy to get your people's opinions about what I should do at this point, but I'll get back to this. So I'm going to cover, and I do it anyway, these various asterisms. I teach the people to do averted vision. Do you do any of that, Chris? You don't do that, do you?
No, I don't get into that detail. But I'm thinking you're going to want to have some of these in your back pocket, because the sky, not all the sky is always visible.
That's true. Okay, that's a good point. Thank you.
Is that a yes or a no?
He told me I should have backups because not all the sky is visible sometimes. And right, usually the way I get around that is it's because of the clouds are going, and I'll do this part here, and when the clouds go, I do that part. But anyway, we'll see. All right. So so is this a good idea, do you think, to do the 6 categories of deep sky objects? Do one each? Any suggestions? Nothing?
It's a great idea, and you just have to adapt to what the conditions are at the time.
Right. Not good. Yep, that's true. So I have some backup. So anyway, here are the 6. So I always start the tour with MIsner and Alcor in the handle of the Big Dipper. Why? Because it's easy to see. I can teach averted vision, and that's the opportunity for the participants to focus their binoculars and get sharp image of 2 stars, right? And it also illustrates the difference between what you can see with the naked eye and what you can see through binoculars. So it's an excellent place to start, and it orients us in the sky. Where are we? So I start with this one, and I go down here. So I have 1, 2, 3, 4, 5, 6. All right, I'm going to go through these. So there's the MIsner and Alcor, and you can get a good view of that through binoculars, and it's a wow factor for people. I see it, especially as old folks who couldn't see it in the first place. Then I come down here, and this is the teapot in Sagittarius. It's an easily seen asterism, and M22 is right about there. And you can tell them the top of the teapot is right there, and they're going to put that in their view at about 7 o'clock. And when they do, they see this star down here, and I tell them about these 3 stars, and just look to the left of that, and what do you see? Works every time. People go, oh, I can see it, I can see it. Now, Dave would tell me that you're looking at something a little low on the horizon. I'm doing that on purpose, because if you've ever used binoculars to look at the night sky, you want to be doing this. You do not want to be doing this. I've had people come to me 6 weeks afterwards and say, I'm still got a sore neck from that night you took us out, that sort of thing. So I've been very aware of that as an issue. So this is good, and then I spend some time telling them all about that particular globular cluster, what it means, how many stars are there, how old it is, and why it's so cool. So that's the first one. Now, this is, I don't know which is which. I think this is M3 here, and this is M13. These are all my pictures, by the way. Here's the point. By the time we get to the telescopes, this may be much lower on the horizon and not really a good target for telescopes. That does not matter. If you've seen a globular cluster, you've seen a globular cluster, you've seen them all. Not quite, but only the experts could tell the difference, or some of you people. So they could focus on M13 or M3 and say, you saw M22, we're focused on another one, but they're both globular clusters, blah, blah, blah. That make sense? Okay. All right. And then we have over here, I tell them, go to the left side of the lid, go that far again, and slightly to the right, what do you see? And they will come back and say, I see the M8. So I'll talk to them about that. What is this? And this leads to open clusters, because this is the first stage of an open cluster. And anyway, this is bright, very bright, out at Nova East, Smiley's Park. So it's a good second target, and they're close together to each other as well. So that's advantageous. So that's 2. If M8 is no longer available, then I'm suggesting you might want to go up to M16 and M17 up here and use them as a telescope target. There's your fallback. And one reason I focus on the teapot is that there's so much all around the teapot that they can see. This is just a few of them. And what have I got over here? So there's M16 and M17. The next 2, Lyra is my favorite target for a double star. Often, if I have a group around me and it's just past sunset and we're waiting for astronomical twilight, if I can see Vega, oops, a daisy, sorry. If I can see Vega, then I start with the famous Canadian star, known as the double-double. And they like that. And we can see it because it's stars, right? I mean, you can't see nebulae, you can't see galaxies, but by God, by first thing in the evening, you can see stars. So that is an advantage, and also open clusters. So Oh, that's my, I'm doing it backwards. Actually, the first thing, because it's also stars that I go for, is the asterism, the coat hanger. So I have to tell them about the summer triangle. I do that, and then I say I draw an imaginary line, go 2/3 down, and just past Alberio, the eye of the swan, and see what you can find. And they almost always find it right off the bat. So it's a good target, and it blows them away. It's so cool, and and because they range in distance from 200 to 800 light years away, you can tell them about the ones 800 light years away have to be 4 times brighter and all that sort of thing. So that's a big hit. Now the problem with this in particular is here. To see this, you're looking straight up. So I've minimized the number of times you have to do it, but this is such a great target. I say, well, some of you may not be able to look at it for very long, but here it is. And so, whoops, sorry. So what happened? I hit the wrong button. There we go. And so I tell them all about this multi-star system, and then the fact that our sun is unusual by being all by itself, and so on. And I get them to look over here, and I say, what do you see? And they say, well, it looks like a peanut. They can't quite separate it, but they can see that it's not a round star. And I point out that's another double. So then we come over here, and next I show them Andromeda. It's a good averted vision target, and easy to find once I give them directions. And oh, here we go. And that's the view that they get. So this last star over here is this star here, and just up and to the right of it, this is what they see. And probably Andromeda is best seen through binoculars anyway, right? Right. Okay. So that's the next target, and it's lots to talk about: how far away it is, when it's going to collide with our galaxy, and how big it is, and things like that. Now, normally in the summertime when I'm talking about open clusters, the first one I will show people is MEL 20. To me, it's the best, for educational purposes, it's the best one to show, because when you look at it, and this is from Stellarium, what you see are 15 stars. So they fill the view. So when you're telling people these were all formed at the same time from a big dust cloud, blah, 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 this makes a lot of sense to them. Most of the ones you see may not. However, most people wouldn't use MEL 20. Most people would use the double cluster here. You can just barely make it out. And it's another averted vision target. It's right there. And so I tell them visually to go here to here and then go down twice and look around, and they should be able to see it. And almost everyone can see the double cluster with the naked eye. Then we go up and look at it, and this is where people have problems. Why? Because it's sort of in the Milky Way. And there's a lot of stars in the Milky Way. And people have a hard time distinguishing the double from the rest of the Milky Way. So that's the weakness there. But I mean, it's advantageously, it could be a target for telescopes if people want to focus on these as well. So any thoughts on that? Whether I should go with this or focus on the double cluster? Yeah.
Okay, because that one binocular on stand tripod, say focused on that, they don't have to find it, they visit it.
Yeah.
It's hard to find. It's up in the sky, put it on a tripod.
That's very true, because I don't have 20 tripods. Well, yeah. If I had a choice between that and showing this is what I would do. I would go over here. But you're right, it's easier to see. I mean, we know jiggle is, things disappear with jiggle. And this is, it brings up another small issue, is that I have zeroed in. I used to have a collection of 7x35s, 8x42s, is that right? And 10x50s. I'm almost all 8x42s now, because they're optimal for looking, and much less shake for people, so they see things better. Anyway, so when we talk about the telescopes now, two things. First of all, they don't have to be the same targets. They just have to be in the same category of deep sky object, right? So that's where the coordination has to be, not necessarily the exact same target, although it would be nice. So the globular cluster could be M13 here. Now this, or Albireo here. Now, this is not my photograph. Someone's enhanced the color, but it is one of the most fantastic sights that you can see through a telescope is Albireo, just simply because the difference in color is so obvious. Yes, Judy?
Last year when that was shown through the telescope, there was a woman that saw it. She said, they ever far apart? Because you see them through binoculars and they're a little distance, then you go see them through that mechanism and they're brighter and they're further apart than what she imagined.
Right.
They do see the difference of going from one to the next.
Yeah. And if all our participants were around 10 years old, I would use Albireo because they can pick it out just so fast. But us oldsters, not so much. So I would recommend the telescopes, when we talk about double stars, would focus on Albireo. And I've gotten good at having people find M13 using binoculars. And the reason is, it took me a little while to figure out that you have these two stars here. And if they put this star up here at about 11 o'clock, then these stars pop out, and this may be dark, but if they use averted vision, it becomes quite clear. So that is another possible globular cluster target. And the one thing that's missing from my binocular categories are planetary nebula. We have two up there that I think we could use, and that's M57, the Ring Nebula, and what the heck's that one? I forget. The Dumbbell Nebula. Come on, what's the M for Dumbbell Nebula? 27, thank you. I'm good to know you're awake out there somewhere. Oh, right, it's on the screen. Duh. Thank you for the obvious. They are paying attention. Thank God for that. Okay. So I do a lot of outreach, and this is a typical group from my scans class in Liverpool. And what you see here is this isn't the guy that's in my class. This is Wayne Mansfield. Thank you. I know so many Waynes. And this is his 8-inch push-to telescope. Wayne knows every inch of this guy. And we will be looking, you can see all these people have binoculars. We'll be looking at something, whatever, the double, whatever. Anyway, the point is, he'll already have it in his view. He can do it just like that. And so when we're finished doing this, they walk over, they take a look through the telescope, they see it, and then we go to the next object. So this is the way we do all of our outreach, he and I. Going from the binoculars to the telescope is an amazing experience for people. They tell me over and over again. And this is what I'm trying to replicate on the field during Nova East, is going from the binocular to the telescope. And so what we have here is for the telescope view, I would say for double stars we want alberio. Maybe the double-double if we can separate the pairs, but I don't know anyone has a telescope that big. Galaxies, if there's a very wide field view telescope, then Andromeda might work. Otherwise, I'm suggesting almost any other photogenic galaxy. Open clusters, the double cluster might work, but again, any other open cluster would work. Globular clusters, we saw 3 of them there. Any of those would work. Nebula, suggested those. Planetary nebula, either of those. I don't know if is it worthwhile for a telescope to be focused on an asterism? Not really. Okay, I'm glad we all agree on that. And in terms of display, it depends on the individuals, what they feel that they want to display here. I mean, David was doing it last time. Jerry, were you doing it as well? Yeah. Was anyone else doing display? Okay, Peter. I mean, that's probably enough. What do you think? Should we try?
We have 5 telescopes identified.
Yeah.
Jerry, Hoskin, Karen,
Hamlin.
Hamlin, thank you. I was going to say Hoskin, that's wrong. Mike Gatto.
Are they doing display?
Some of them will be, yes.
Oh, well, no, it's just 5 telescopes and 5 telescopes in total, are you saying?
Yes, they'll be identified as part of this program.
Good, I need 6. We got to get one more. Any volunteer here to add your name to that list? Peter, I think he's already on the list, isn't he?
No.
Oh, thank you, Peter. Yay.
Okay.
Great to get.
4 to 9, not 4 to 8.
All right. So just to recap, naked eye observing, binocular views, telescope, and enhanced imaging. And we have to, we're going to try and keep it in the timelines. What's the schedule there? When are they supposed to stop using lasers?
No one sees lasers, except the people that are involved with the program.
Okay. What time is regular observing and astro imaging supposed to start? Okay, so we're trying to make sure that time-wise we're below there, and all the rest of it, you know. So what I'm asking you is any suggestions for improvement to what I just showed you, or enhancement, or anything you feel should be changed?
One thing that would be helpful, Tony, especially for the binocular people, as you said, you don't want to bend backward too much.
Yeah.
Have one zero-G chair that people can sit in, recline it, find the target, and then let the next person get in.
Yeah, okay. I have 2 zero-gravity chairs that I can bring. Does anyone else have some? I mean, any chair will do almost, but okay, we could do that. What, the zero gravities? Yeah, I know. But not everybody has a hard time with it, you know. So younger people might, whatever. That's why I was saying regular chairs also help. You know, if you're sitting, you can do this easier. So that's a good suggestion. In fact, when I do outreach, I ask people to bring their own chairs. So a couple of points. I mentioned that I'm going to have, my plan to have like 20 copies of description of the targets, right? Does that make sense to hand that out?
You should include more than just your minimum to account for clouds.
Yes, okay. So, yeah. So for backup and all the rest of it, I may have under double stars, I may have the double-double and the alberio. And that's good enough, even if we don't look at that. The other point, so you're looking after volunteers? Judy, you're looking after volunteers? Okay. But you're looking at your volunteers, right, for all this? And you're assigning people their tasks and so on. Okay, good. The final point, wake up, Peter, is should we be doing some of this at Dark Sky Weekend? Because right now at Dark Sky Weekend, I do my ACE Amateur Astronomy program. And is this something we should try there? And then, because we usually have quite a few telescopes out in the field, but they're not organized to look at different things. And I know some of you are at those telescopes. It's like herding cats. No comments?
We don't have the same commitment to telescopes at DSW, right?
I know what you mean by commitment.
We're not sure who's going to show up
Oh,
as much.
yeah, well, we usually do ask for volunteers, and volunteers show up. So I don't know. But, okay. So what you're saying is that we have less control. I mean, what we do now works. And maybe what we should do is get it working at Nova East and then consider Dark Sky Weekend, whether we want to. I mean, I can change my program there. And I would go through people a lot faster than I do now. Instead of doing 3 shows a night, I might do 5 or 6. No other comments? Yeah, well, my voice starts to go. That's why I have the mic. Any other comments? No? Okay, well, that's all I have to say. Thank you.
Thank you.
I just want to thank Tony for the presentation today. Well, certainly, Tony, if you could send us the presentation so that we can then examine it, and we have it? Oh, okay, we have it. Lovely. In other words, I have it to make the assignments, right? Okay, I think next is the news from the board, right? The update from the board? Okay, so that would be another Tony McGrath, our president. There you go, sir.
Thank you, Judy. Okay, let's have a quick look at some items from the board. Keep it, yeah, not too far. This thing down. Just wanted to share we had a note from Joshua Kutrick to the RASC. Joshua's Colonel Kutrick is going to be launched to the space station, I think in September this year, as part of the Canadian Space Agency effort. And he did a presentation to an RASC center and sent a very nice thank you note. The scope fund is, we've reached the $25,170 of the scope fund. We continue to fundraise in the sense that the astro imaging, sale astro images is still available, so you can check on the website, and there's a link to order some we're very lucky with the imagers we have in this center and some of the photographs and the images that are available. So we really encourage you to have a look at those. Okay, so they changed, so don't hesitate to go back. Nova Notes. I've had it's amazing how lucky we are to have Nova Notes, and Lisa Ann Fanning and John McPhee do a fabulous job. And so I hope everyone takes some time to look at the current issue. and consider contributing too as well, because it's a wonderful thing that we have here in this center. This is we're getting ready for a maintenance at St. Croix, a cleanup weekend, or cleanup day rather. We're scheduling it for the 13th of June. So we encourage anybody who's available to come out and give us a hand. We have a bunch of work to do at the grounds. There's a bunch of weed, brush clearing, tree branch removal, that sort of thing. The observatory building needs a general cleanup. We've also got some electrical issues, so if we have any electricians or folks who, in the center who are knowledgeable in that matter, it'd be nice to have you out there with us. The warm room needs a major cleanup, or not a major cleanup, or it needs a cleanup. We've got to remove those solar cells and ancillaries from the building. They're no longer used or necessary, so we kind of want to get those off. The storage building needs a bunch of work as well, in terms of just generally clean up. And when I say a bunch of work, it's mostly cleaning and that sort of thing. There's a diesel generator out there that we want to get rid of. So, if there's anybody interested in gasoline-powered generators, to come out and have a look at it. We want to remove it from the site, and if it's worth, if we can sell it, we'll sell it. Just a quick note about personal protective equipment, because we'll be working with some power tools, doing brush clearing and that kind of thing. So think about safety, gloves, coveralls, eye protection, that sort of thing. Ticks are an issue at St. Croix, so there's some tips here about how to minimize your exposure. If you're able to come out, bring some tools with you. We don't have any tools out there, so things like for weeds, small axe to dig out some weeds, weed whacker, pole saw, shop vacuum, those sorts of things. I'll get this posted somewhere, so this list of things, so you folks can have a look at it later on if you're thinking about coming out and get an idea of what has to get done. So that's the 13th of June. If the weather does not cooperate, just watch the list and I'll let folks know about what the rain date might be.
Bring your own lunch.
Bring your own lunch. Thank you, Judy.
That list you want to add some N95 masks. There's a bunch of other stuff to be cleaned up.
Okay, thank you, Blair. Very quickly, just again, we're coming up to the end of the year, so the RASC Awards, the deadline is the 31st of December. So if you have, if there are folks in the center that should have their efforts recognized, now is the time. All the information is available on the website, so I won't go through that sort of stuff now, but it's available on the website. So have a look. December will be here before we know it. As well, I'd like to encourage folks on these observing programs. Again, they're available on the website. So have a look. They don't require, like, there's a list of here, like you can see, you don't need to do the complete list to be eligible for the certificate. There's, in some cases, they'll give you a menu, and there's so many of that menu, and you'll be eligible for the certificate. So the board of directors, if you need to get in touch with us, have any issues or comments or questions or queries, we're available just via email. National Council, of course, Judy is the chair of the National Council, and also available if you have any, from a national perspective, any questions or queries. And the next meetings we have coming up, we're working on speakers for September the 12th and October the 3rd. And in November, Blair is going to address us on his finding exoplanets. And in December, we have John Badowski on the Fermi paradox. So stay tuned for the September and October. We've got a couple in the pipe, but we're just working to finalize the details of those. And with that, I'm going to let Judy have a yarn with you. Nope. Okay, please.
Yes, we're playing. Yeah. I'm going to stand here so I can manage this. Thanks, Tony. Coming up is actually the 17th annual Kejimkjuik Dark Sky Weekend. It is the weekend of August the 7th to 9th. It is currently on their website as being an event, but at this point the actual scheduling of events has not been determined. Am I correct in saying that, Peter and Tony? Yeah, so if you're interested, just keep looking at the Keji site and you'll find the DSW there. Oops, turn this around. So mark your calendars, and if you aren't a volunteer and you think you might like to, in fact, we might be seeking more if we decide to go with the program that Tony's proposed, please let Peter or Tony know that you're interested in volunteering for it. And then there's our star party. Believe it or not, it's the 38th annual Nova East that will be hosted this year again at Smiley's Provincial. The theme this year is the sky from near to far, which means it encompasses just about anything that when you look up, it's there. One of the things that the team did this year were two things. One was our typical tagline for years has been, the stars belong to everyone. We decided that it was time for a change. And so we wanted a tagline that related specifically to Nova East. And so it became, what does Nova East do? Well, we gather under the stars. So that was our tagline. Thanks to Michael Gatto, he suggested, well, we should really have a Nova East logo. So he designed several, and this is the one that the team agreed to, which was, it's a very easy flowing font, but if you'll notice that the stars fill in the A's and the E's, and the moon fills in the O, so that we've got the near and far even in the logo. And of course, the dates have been extended from the usual like the Friday night to Sunday or Monday. We've extended it 2 days earlier this year because of the Perseid meteor shower. We'll get more into that in a bit. So, and I'd like to point out, it's not just for members. If you know friends and family members that are interested in astronomy, they're welcome to come join us. In fact, that's how Jerry and I got involved, because we were non-members and attended a Nova East. So it's for anyone that's interested in astronomy, not just for RASC members. We are really thrilled this year to have a significant keynote speaker, Dr. Catherine Lovekin from Mount Elsa University. She's going to be talking to us about looking at stars beyond the surface. When you and I look up at the sky through whatever means we look up at these stars, we see a certain appearance. Well, she's going to describe what can you glean from some imagery to determine what is the core of these stars, what is it composed of, and how does it reflect differently in our eyes. And another thing too, she isn't just speaking on the Saturday night. She's with us all weekend, so we have a whole lot of time to chat with her while she's visiting with us. The fees for camping this year, we had to increase them slightly, but the camping per night has changed the same. And this lovely image is the design on our t-shirt. So we have Frank Logan to thank for this. And it encompasses every aspect of the sky from near to far. It's got the part where you see the various colors in here is the nebulosity of between us and whatever else we're looking at. We've got the moon, which is a near item. We've got the galaxy, which is far. We've got these stars that are spiked because of, the telescope, the way we look at it through the telescope. Not to mention, we've got the Big and Small Dipper, where the Big Dipper points to the Polaris, which just happens to be a star in our logo. So it's very well thought out, and thank you so much Frank for designing that. T-shirts are $25. They have not increased in price, but if you want one of these babies, you have to order them before July 3rd. That's the deadline for ordering, because we have to order with a company for printing prior to our event. And the T-shirts are white background, by the way, just so you know. And a toque, and it's got the Nova East logo on it, and they're $20. This is something, yes, we're selling for Nova East, but we do plan to order more than we need for Nova East, so that we can then sell at meetings or outreach events or other events that we sit at. So that item will be in essence evergreen compared to the T-shirt, which is not. And of course, before we show this, I just want to make note of the fact that we do have the standard things at Nova East. We have the Astro Breakfast, we have the Astronomer's Lounge. This year we are having a swap table again, so if you have any items that you want to bring in and sell and or swap with other people, please do so. That's equipment, books, whatever. And we have 2 sponsors this year, and we're really pleased to announce that Atlantic Photo Supply, who's been a long-time supporter of us, have come through with a Celestron Star, let's see, get my glasses, Star Sense Explorer 130 Dobsonian tabletop telescope. So that's our grand prize. And Telescopes Canada's come through with 2 $200 gift certificates, along with 2 hoodies and a couple of toques as well. So we have thanks very much to our sponsors for that. And rather than me standing here telling you about, and we've got this and this and this, we've got a video. And in case you want to see it again, it is on our homepage. And I have Jerry Black to thank for developing this for us. So Jerry, if you would play it, please. Door prizes. Okay. Any questions about Nova East? And if I went through too fast for you, just go back to the website and reread it, or go to the schedule on our website. And more importantly, I guess I should really make the announcement official. As of about 10 o'clock this morning, the website is live, so anybody can register for the event now. The information is all correct to 2026, and the registration form is accessible. So I invite all of you to please come and join us out there. It's a lot of fun, a lot of socializing. You get to learn a lot, not only from the speakers that we have, but also from each other. And so come see us at Nova East. Oh, no. So just as reminders, our next public meeting is September 12th, so you've got the summer off to enjoy Dark Sky Weekend, Nova East, and all your other observing sessions you'd like. Don't forget that the national annual meeting is on June 21st, and they've advertised through the RASC Weekly, I believe, for the last couple of weeks on how to register. Please attend. Your attendance is really critical. You're a member. You should know what's going on and also ask questions. And also a reminder, Dark Sky Weekend at Kejimkjuik on August 7 to 9, and of course our very own Nova East on August 12th through 16. And that's it. Thank you. Oh, sorry. Chris has a question.
Well, it's actually more of a request or perhaps an opportunity. As you know, from talking with Tony,
Oh, yeah.
I will do the sort of the sky tour at Dark Sky Weekend and also at Nova East. And that usually involves I try and get across some familiarity with the sky, so to find their way around a little bit. And I give some, I guess, cultural astronomy kinds of stories. And I'd be happy to have somebody else who would perhaps join me and participate in that. I have quite a few resources in terms of stories and things. It's not a particularly long thing. I think Tony's given me 45 minutes, which
30.
30?
30.
30's workable. Yeah. Anyway, so if anybody is interested, you can get in touch with me or maybe Judy. You might
Sure.
be clearinghouse
Yeah.
as well. And I'd be happy to meet with you and share some information and talk a little bit about it.
Yep. So, yeah, I will summarize it, but nonetheless, because I have to add to that as well, and I forgot, thank you for reminding me. Chris Young has just noted that he would like some assistance with the Skylord portion of the program. He has background information he'd be willing to share with you, and keep in mind it's only a 30-minute presentation at the beginning of the evening observing sessions, so that it wouldn't be long. Let's put it that way, right? Yeah, nor is complicated. Yes, as perhaps what maybe Tony may have indicated. To add to that, right now we have 3 individuals that are willing to do the binocular portion of it. I would like 1 or 2 more people. Again, like Chris, we have, and Tony has, information about each of the items that we'd be looking at. So it'd be just a matter of you being able to describe how to find it and have this learn the descriptions of what that star or nebula or whatever is. So if you're planning on attending Nova East and you would be able to assist either Chris or the two, actually Chris and I are 2 of the people at the binocular table too, along with Karen Hamblin so far. We would like 1 or 2 others to assist in that endeavor. So if you're open to volunteering, and we'd be willing, and keep in mind that we will have a practice session with respect to the binocular tables, just so that we can figure out what we're doing, how we're doing it, and that sort of thing, so that we're familiar before we get out to Nova East. So thank you.
Okay, so we'll end off with what's up in the June sky. Anyone recognize what that is? Yep. Okay, so short nights in June. We're leading up to the summer solstice on June 21st, which will be at 5:24 a.m. in Halifax. We're under 4 hours of darkness throughout the month, so short nights for the imagers. This is the what's happening on the sun today. A couple large sunspot groups, and I draw attention to 4456, which is the even though it doesn't look very impressive, it's the most active of the groups, and it's a source for potential M-class solar flares. So we were hoping for some aurora on Thursday, late Thursday, early Friday morning. The sky was clear, but the coronal mass ejection arrived late. Rejection arrived late. I noted a KP6 at about 11 in the morning on Friday, so that wasn't useful to us. But anyway, maybe 4456 will do something for us. We're now in the season for noctilucent clouds, and these are really, really pretty after sunset. They're formed by sunlight below the horizon, reflecting off ice crystals that are very high in the atmosphere, around 80 kilometers in height. And they're seen during astronomical twilight, so after sunset, and in the summer months. And we're fortunate because we're just about the right latitude to see these. I've seen people report them already from Europe. And I took this picture of noctilucent clouds that we had visible in Halifax a couple of years ago. This is the phases of the moon for this month. And you see that there's a new moon on the 15th of June. And that leads up to a full moon at the end of the month. So last quarter moon, the frog's croaking moon will be on June 8th, so a couple days. On the 10th, the moon will be near Saturn, so something to see in the morning. On the 13th, the moon will be near M45, the Seven Sisters. Then, as I said, a new moon, the tree's fully leafed moon on the 15th of June. And then the moon being near Jupiter and Mercury on the 16th, near Venus and M44 on the 17th. Then we have a first quarter moon, followed by on the 26th, the moon being near Messier 4, and then near Antares on the 27th. And as I said, a full moon at the end of the month. So on the 16th, if we have good weather, just after sunset, this is something you want to have a look at in the west northwest, because you'll see that Venus, Jupiter, and Mercury are going to line up quite nicely, and in the middle there'll be a thin crescent moon. So should look pretty nice in binoculars, and a nice wide-angle photo op as well, if anyone's interested. The 17th, I mentioned that moon will be near M44, the Beehive cluster, and in fact it will occlude or partially block the Beehive cluster. And you'll notice that the moon's at this point will be in a very thin crescent phase, and Venus is in the same field of view in binoculars. So any astroimagers that are interested in lunar and planetary imaging, this would be quite a nice shot, because if you get the right exposure, you'll be able to catch Earth light on the moon, and open cluster and bright Venus in the corner.
If it's dark enough.
If it's dark enough, yeah. About 10 p.m. It won't be, not bad. They're pretty bright objects. And on the, as I said, on the 26th, we'll have the moon, a waxing gibbous moon near Messier 4, which is the globular cluster in Scorpius. And then the next night, moon's moved a bit, and it'll be in the same field of view as Antares in 7 by 50 binoculars. Best nights to look at the moon if you're doing Explore the Universe, and check off some of the required features for observing are around the time of the first quarter, so June 19th to the 23rd. And something special event this month. Anyone that, and I expect everyone here that followed the Artemis orbiting the moon, they got some nice pictures, and this is an image taken on the Artemis 2 mission of Mare Orientale, which is a lunar sea on the far side of the moon that you can just barely see through a telescope due to favorable libration. And it turns out that on the 9th of June at 5 in the morning, so you have to get up early, but there will be for this year, this is the most favorable western libration, minus 7.8 degrees, which will expose the features. They're going to be distorted because you're looking edge on at these features, but should give us a pretty good view of Mare Orientale. Just to give you an idea of what you might see, I took this picture maybe a couple of years ago now, and the libration was minus 5.8, so it'll be even better on the 9th. So, and I checked it before the meeting, and Clear Sky says it should be decent. Fingers crossed on the 9th. So, well worth checking out if you don't mind getting up early.
It's a view of the far side of the moon.
Yeah. Yeah. Okay. Planets. So all the planets are currently visible at some point between dusk and dawn. So Mercury's low in the northwest after sunset. It achieves its greatest eastern elongation on the 15th. Venus is prominent in the post-sunset sky. It'll have a close conjunction with Jupiter on the 9th. And I said earlier, being near M44 and the waxing crescent moon on the 17th. Mars is visible low in the east in the pre-dawn sky, so you have to have a pretty good eastern horizon to see Mars. Jupiter still visible after sunset, low in the west, conjunction with Venus coming up on the 9th. And but as the month goes on, Jupiter will be sinking lower and lower in the sky after sunset. Saturn is back in the sky, rising in the east after midnight. And the tilt is changed, so you can start the rings are a little more apparent now. Uranus emerges from the solar glare by the middle of June, and Neptune rises in the east before sunrise. And as the month progresses, Neptune gets closer and closer to Mars. Yeah.
You can actually see Venus, Jupiter, and Mercury in the sky now.
Oh, yeah. Spread out. Yeah, spread out.
We've been watching it the last 2-3 nights.
Cool. This is the on the 9th. So the 9th's a big day, right? I get up early in the morning to see Mare Orientale, and then go out at night to see the Jupiter-Venus conjunction, shown right here. And there's Mercury, as Judy just mentioned, and Pollux is also should also be visible just after sunset, just above Venus. And in binoculars, in the 15 by 70 celestron binoculars, this is what it will look like. And at the end of the month, on the 30th, I mentioned that Mars and Uranus are close together. Again, through the 15 by 70 binoculars, both planets will be in the same field of view. And if you've never seen Uranus with binoculars, this is a good time to have a look, because Mars is easy to find, and then just put Mars at 2 o'clock, and then down around 8 o'clock you'll see Uranus. Summer constellations. So twilight ends late, about 11:30 p.m. Your summer constellations are Cygnus, Lyra, Hercules, Aquila, Sagittarius, Scorpius, and Capricornus. Summer stars, brightest are in order are Vega, Altair, Antares, and Deneb. And these are all stars and constellations that are part of the Explore the Universe program. The deep sky object for June is the coat hanger asterism, and Tony just told us how to find it. So it's pretty easy to find, and a nice binocular target. Basically located a third of the way from Altair to Vega. So draw a line from Vega to Altair, and a third of the way down that line, you'll find the coat hanger asterism, also known as Brocchi's cluster or Colander 399. Summer double stars. The one for June is Omicron 1 Cygni, and here it is, the hockey stick. Very pretty. A red giant, a white star, and a blue star. And you'll notice that they're at different distances from the Earth, so they're not gravitationally linked. They just happen to line up in this fashion. But it's a really nice, colorful triple optical star system, or grouping of stars. And there's a meteor shower. It's the Ariids, and they're a bit challenging because you'll notice that the radiant is very low on the horizon, and that's just before dawn. So you might see a few meteors pre sunrise. So an hour before dawn, have a look to the east if you have a good eastern horizon. You might see some meteors. It's pretty active, 60 to 200 meteors per hour, but the peak is usually during daytime. So you're not going to see them, but if you're interested, you can hear meteors passing through the atmosphere on an FM radio. So I've got a link that you can access from our website that'll tell you how to do this, and or you can just Google it. It's pretty easy. And another object that is part of the Explore the Universe observing program is to observe at least 3 Earth orbiting artificial satellites. So not a problem anymore, right? Choose your satellite. But you do have to identify, which satellites you're looking at. You can't just say, oh, it's a Starlink, I don't think. So the International Space Station's an easy target. And you can find dates and times for when the International Space Station and in fact other major satellites will be visible from Halifax from the heavensabove.com website. NASA used to have a website that told you, but
It's back.
it's back.
Yeah.
Okay.
So like most of the page is still like please download our app, but if you go to the bottom, it tells you when it's going to pass over.
Okay, good. Yeah. So Tiffany just said that the NASA website is back. The rumor was that the Trump regime was canceling it, but that's good. Other bright ones that you can see, the Chinese space station is another one that's really bright and easy to see. So this is a picture I took I think it was like a 1 second exposure, something like that, from Clayton Park, and you can see the trail of the International Space Station. And if you really want a challenge, try to image it with a telescope. It's a tough one to track. I did get sort of a picture of it. 12-inch Dobsonian manual tracking. I think I got, I don't know, 200 or 300 frames, and I had the space station on 30 or 40 of them. So. Okay, that's it for the June sky. So if there's no questions, hope to see everyone at Nova East or Dark Sky Weekend. Otherwise, September 12th. Have a good summer.